lesson on 4.4. It should be completed after you have done your 4.1 to 4.3 quiz in class. Because we are doing this lesson via Edpuzzle, I want to make sure you take this lesson as an opportunity to go at your own pace and to make sure you understand the content by doing the guided questions by pausing. There are only 2 examples in today's lesson, which means there are only 2 guided questions. So those proofs should be done on your own, but give yourself the time to make sure you understand the content. Homework this evening / this weekend is 4.4 Math Excel, just 16 questions. We will be testing on this on a Monday. It'll be on the 30th, which is right before Halloween. Please also make sure you turn in your classwork assignment before leaving. 4.4, the learning target for 4.4 says, I can use triangle congruence and corresponding parts of congruent triangles to prove that parts of 2 triangles are congruent. We abbreviate this expression to be CPCTC. CPCTC stands for the fact that corresponding parts of congruent triangles are congruent. This all comes from the ideas that we learned about in 4.1. In 4.1, we talked about 2 figures are congruent by definition if all corresponding parts are congruent. So what we're going to be doing in this particular lesson is we're going to prove that triangles are congruent using either a side, 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 angle, side, ASA, or angle, angle, side. And once we have shown that the triangles are congruent, we can say that any of the parts that are corresponding are also congruent by the definition of congruent triangles. Here is our first example. In our first example, we have been given that angle KBC is congruent to angle ACB, and angle K is congruent to angle A. Notice a difference with what we're trying to prove now that we're in 4.4. In 4.4, we're trying to prove that segment KB is congruent to segment AC. So our goal is to be able to add these congruency markings into our diagram. But in order to add those congruency markings into our diagram, we must first prove that the triangles that create those 2 are also congruent. So I want to prove that my green triangle is going to be congruent to my blue triangle. So essentially, this is kind of like prove number 2. That's our ultimate goal. Before we can prove that fact, we must first prove that the 2 triangles are congruent. So we first want to think about, well, how can I prove that these 2 triangles are congruent to one another? So we always are going to start off with our givens, and we're going to do this as a flow proof. These are going in 2 separate bubbles because they are 2 separate givens and they are not connected to one another. So I know that these 2 facts are for sure true, and I've already marked in my diagram, I'm going to erase everything else, what I know. I know that these 2 angles are congruent. Now looking in my diagram, I'm trying to figure out, is there any other information that is indeed true about the 2 separate triangles? And the easiest fact for me to bring up is the fact that our 2 separate triangles share this common side. And as we know, if 2 triangles share a common side, the absolute best thing for us to bring up is the reflexive property. So we're going to bring up the reflexive property here. And so if I add that congruency now into my diagram, we know that BC is congruent to himself. We know that the 2 triangles are congruent by angle, angle, side. So the 2 triangles that are congruent by angle, angle, side would be triangle KBC and triangle ACB. Remember, corresponding parts do have to match up. And that was through angle, angle, side. Well, now that we know that the 2 triangles are congruent, we know that all of their corresponding pieces are congruent, their corresponding parts. So we may now conclude that segment KB is congruent to segment AC because those are corresponding pieces of the 2 congruent triangles. So our reason becomes the corresponding parts of congruent triangles are congruent. Now that becomes really wordy to say, so we simply say CPCTC. All right, my friends, it is now your turn. Here is your got it question. You are given 2 sets of congruencies, and your job is to prove that angle C is congruent to angle E. Remember, you must first prove that 2 triangles are congruent in order to prove that their parts are also congruent. Please pause the video at this time and take the time to prove this statement. All right, here is your answer. Okay, notice that I gave it to you in a paragraph format here. The piece that I should see in your proof, I'll highlight it for you. The fact that we should all bring up is the fact that we have vertical angles, okay? So we want to bring up the fact that angle CAB is congruent to angle EAD by the vertical angles theorem, okay? So therefore, by side angle side, we know that these two triangles are congruent, and thus by CPCTC, angle C is congruent to angle E. Those are the steps I'm looking for. All right, here comes my last question for today. It is a quote-unquote real-world problem here, and so we have a picture, and I have been given that these two triangles that are created, we have triangle SRT and triangle LRT. Inside those two triangles, we have right angles, okay? So if I just take my little highlighter here, we have a right angle here, we're gonna have a right angle here. Please recall there is a fun fact about right angles. We're gonna have to use in our proof. I also know the fact that this angle RTS is congruent to this angle RTL, okay? Ultimately, my goal here is to prove that RS, this side right here, is congruent to RL. All right, so full disclaimer, there are many, many different ways to prove this particular situation, okay? All right, so here we go. Starting off, we start off with our given. We already know that angle RTS is congruent to angle RTL. This has indeed been given. As I mentioned, there's many, many different ways to prove this particular triangle set, but the ultimate thing that I would like to bring up in order to conclude my pink highlighter marks is probably the obvious piece that these two triangles share RT. Okay, so I'm going to have to bring that up, and that is through the reflexive property. You can say that RT is congruent to RT, or you could say that TR is congruent to TR. Now, the other given that was brought up was the fact that TRS and TRL are both right angles. And there was a theorem that once upon a time we learned about. We learned that all right angles are congruent to one another. Remember, if you might, there is no cute name to this particular theorem. That's why we just utilize the fact that all right angles are congruent. So what I have just done is I've created an angle with a side and an angle in both triangles. So ultimately, we are able to conclude that these two triangles are congruent. So triangle TRS is congruent to triangle TRL by angle, side, angle. So ultimately, I can say my pink congruencies that I wanted to add into my diagram are true by CPCTC. RS is congruent to RL. All right, friends, that was your lesson for today. So here is your last got it question. In question A, you have a proof to do. You're ultimately proving that angle AMB is congruent to angle AMC. And in question B, I want to talk about the fact that the landmark was not at sea level in that previous problem. Would that work? Explain. So pause the video, take some time to formulate your responses, and then we'll check your answers. Here are your answers. So things I am looking for in your responses to today's got it question. I'll highlight them for you here. I should be seeing you bring up the fact that because I have a midpoint, okay, the definition of the midpoint's a good idea to use. We know that BM is congruent to CM, okay? So you'd be able to add in these little double congruencies here. So now I have one set of sides, two set of sides, and the easiest one, our favorite one to always bring up is the reflexive property here. So I'm going to bring up the fact that AM is congruent to himself, and so this middle piece in here is going to be congruent. So therefore, by side, 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 SSS, we know that the two triangles are congruent, and because the triangles are congruent, we know all the parts that are corresponding are congruent through CPCTC. Looking to our last question, if we were not at sea level, we would not be perpendicular, aka would not make right angles. Therefore, I would not have another angle to talk about in this particular problem. That is why it is necessary. All right, so you're probably still in class with me at this time. So if you had a question you wanted to talk about, please feel free to raise your hand. I'm happy to come on over and talk to you. Otherwise, you're just able to work on your Math Excel for this weekend. Have a great day.